Okay, so now we're back, let's see when they give you the angle of elevation in terms of a trig function here. Let us start with this one. This is the one. In a game of indoor football, a free kick is awarded whenever a ball is kicked above a shoulder height. The ball is initially at rest on a floor when player exits with the velocity 14 meters per second at an angle of elevation. This taking the shoulder height of 1.5 meters, find whether the free kick was awarded. So, was it awarded when someone was kicked? Was it awarded if someone kicked it at 14 meters per second? And then using the angle of elevation like that. In simple terms, if you have to draw a simple sketch for that, we are going to assume this was so someone is kicking the ball here. So we are taking now the initial velocity there. Because the ball was on the floor, initial velocity was 14 meters per second. So now we want to know when he kicks at it at this velocity and this angle of elevation, what height is it going to reach? If it goes beyond this, then the free kick will be awarded. So in simple terms, we are asking for the height, this one here. So how do we get that height? When the ball is traveling at this speed, we need the angle of elevation is there. So how do we do that? So in simple terms, we are taking the time of this, the height of this frame. How do we get the height? Remember, our height is given by u squared sine squared theta all over 2d. But now here they are giving us our u. So here we have our h equal to 14 squared into. We have our sine theta. Remember, our sine theta is equal to 2 over 5. So this will be equal to 0.04. 2 divided by 5. 0.4. So when I put here, I have 0.4, the whole squared. Then I'm dividing with 2, then 9.8. I want to know this height. The height of this ball is going to reach at the maximum height of this ball. So it's going to be now 14 squared. So it's going to give me 1.6 meters. So when the ball is kicked at this velocity, the height is going to reach is going to be 1.6 meters. Meaning, if it goes beyond the shoulder height, whenever the ball goes beyond this height, the free kick is awarded. So because he used this velocity, the height is going to be reached. It's going to be there. So therefore, free kick was awarded. Kick was awarded because 66.5 meters is greater than 1.5 meters, as simple as that. When it comes to this, a golfer hits a golf ball a velocity of 44.1 meters at an angle of this above the horizontal. The ball lands at a point which levels with the point of projection. Find the time for which the ball was in the air. So in simple terms, we have a golfer. The golf ball is here. So when you pick it, it's going to come like this, then it will fall. They are going as it falls at the point which levels with the point of projection. So this man is hitting it with the initial velocity of 44.1 meters per second. So this is always our u. So after hitting it there, now for us in simple terms, they're asking for the time of the flight. They are giving us this at an angle. So now our theta here is given by sine inverse of 3 over 5. This theta here. So they are asking for the time of flight. So time of flight. The time is spent in the head, of course, from here to here. So our t we say is given by the time of flight is given by 2u sine theta the whole over B. So now from here, all we need to get our sine theta. So because if our theta is equal in sine inverse of 3 over 5, don't go to get the angle you're wasting time, you need the sine theta. So from here, just come and say my sine theta, if you reverse this, you'll be having 3 over 5. Then you can substitute here. So the time of the right is going to be now 2 into 44.1, then into 3 over 5. Now all divided by 9.8. So our time here, the time which the buffer was in here, from here up to here, the time which was in here. In simple terms, we are asking for the. So 88.2 divided by minus 3 divided by 5 divided by 9.8. Here I'm getting 5.4 seconds. That was the time it was in the air. Why? Because the velocity was high, so the speed was very high. So now from that, I think you see from here now we are building to this. Then from here, if we have this, now we are applying the ID. Now what happens is if they give you a turn, the ball is protected from horizontal ground and has an initial velocity, so it's straight. So I think that has an initial velocity of 20 meters per second. So this is our U. And at an angle of elevation, so they are giving us theta. So this ball is projected like that. So they are giving us theta as tan inverse of 7 over 24. It's traveling horizontally. It strikes the vertical wall. How high above the ground is the level that its impact occur? So now it's going to strike. It's going to strike a certain wall. This is how this ball is going to strike. Like that. So how high does this strike, or I mean the impact, occur? So now it's that the angle of elevation, it's given in terms of time. So what are we going to do? We need to get sine. In simple terms, they are asking for the height here. At the height of the striking, the velocity is going to be 0. The initial velocity, I mean the final velocity there is going to be 0. So now we know that our theta is given by tan inverse of 7 over 24. If you want from here, you can just get it. By now, so that what is our height? We are going to use there are many ways you can get this. So using, if they want height, you can say b squared is going to be u squared plus 2as. But remember, it's going against gravity. So now we are going now to take the by. So our b squared y is going to be u squared y, then minus 2b. Now we want this height h. So now at this height, at h, let me call this point h. At h, by, the final velocity is 0. The maximum height there is going to be 0. So putting it here, I have 0 equaling 2. Remember, our uy is given by this uy. Hope you remember it. It's given by our uy is always given by u sine theta. So you have now u sine theta, the whole squared, then minus 2d h, and from here that my h would be equal to u sine theta, the whole squared over 2d. So when you need sine theta, you can even get the angle here, but to be more accurate, you can just use the right angle triangle. Feel free to get the angle if you want, and then you just substitute in here. And if you use the right angle triangle, if this is theta, then the opposite is 7, this is 24. Then this one is going to be this plus this squared plus this squared, this would be, so here I'm going to be having 25. Yeah, because these are the ratios there. So meaning that now our sine theta is going to be 7 over 25. Putting them there, we shall get now our u. From there, our u is 20, then times sin theta, which is 7 over 25, the whole squared, divided by 2 into 9.8. And so, the height at which this impact is going to occur by 4 here I'm getting 1.6 meters. 1.6 meters. So that's where the impact is going to occur. At this point, that's where the impact is going to occur. As simple as that. So that's how we handle when they give you inverse functions or when they give you trig functions. It's up to you. But here, if you don't know how to do this, please feel free. Get the angle, just set theta equal to tan inverse of this, then you get that angle. But the problem with this one, it's going to give you some errors. That's why we always go with this one, because here you get the real value of sin theta. It's always opt for this. Okay, so that's it. I wish you well.